In this video, we are going to learn how to solve polynomial inequalities algebraically. So another way to solve an inequality is to set up a table or what's called a sign diagram. And this is going to contain intervals. The intervals are going to come from the roots of our polynomial function. There are 4 steps that we want to follow in order to solve inequalities algebraically. The first is we're going to find the critical values, and the critical values are the roots. Then we're going to place these on a number line. We're going to then test values in each interval to determine if it's going to give us a positive or a negative value. And finally, we're going to find the solution. Let's take a look at an example then. We've got solve negative 2x cubed minus 6x squared plus 12x plus 16 less than or equal to 0. First thing we can do here is we can factor out a negative 2. If we do that, we're left with x cubed plus 3x squared minus 6x minus 8 less than or equal to 0. And then we're going to have to use long division in order to find a factor for this polynomial and to factor it out. What I'm going to do is I'm going to skip ahead, but you should try your long division and make sure that you find the following factors. So we would have x plus 4, x minus 2, and x plus 1 less than or equal to 0. That means then that we've got a root at negative 4, we've got a root at 2, and we've got a root at negative 1. What we're going to do then is create a number line, so just a straight line, arrows on either side, and we're going to place our 3 roots or our critical values on the number line. So we got negative 4, negative 1, and 2. And then what we want to do is check values within each of these intervals. So looking at the interval of values less than negative 4, what you're going to do is pick a value, say negative 5, and then plug it back into our polynomial equation. If you did that, you would get a positive value. Looking at our next interval then, we want to look between negative 1 and negative 4, so pick a value like negative 2. If you pick negative 2, plug it back into this polynomial function, you should get a negative value. Continuing on, we're going to look at the third interval between negative 1 and 2. A really great number here is to pick 0. So plugging in 0, you would get a positive value. Finally, we look at values greater than 2, so pick, say, 3 and check 3. If you plugged in 3 back into this polynomial equation, you should get a negative value. Now they are alternating here, positive, negative, positive, negative. It's not always going to work out that way though, so you have to go through and check every single interval. What we're now looking for in this inequality is values that are less than or equal to 0. So we are looking for intervals that have got negative values. The 2 that have negative values are values of x that are greater than 2 or values of x between negative 4 and negative 1. So that means our solution for this problem would be negative 4 less than or equal to x less than or equal to negative 1 and x greater than or equal to 2. We're using greater than or equal to signs or less than or equal to signs because we've got a less than or equal to sign in our problem. If this was just a less than, then these would all be just less than signs as well.